Hi, welcome to this Corbettmaths video. In this video we're going to look at trigonometry, and we're going to look at using trigonometry to find the size of missing angles in right angle triangles. Now before you watch this video on finding the size of missing angles, I'd highly recommend you watch the video on Corbettmaths, an introduction to trigonometry, and in that video I go through how to label the sides of a right angle triangle, so the hypotenuse, opposite the right angle, the opposite the angle that's involved in the question, and the adjacent. And I also go through the trigonometric ratios, which are tan vita is equal to the opposite divided by the adjacent. So if you do the opposite divided by the adjacent, you'll find the tan of the angle. The sine vita is equal to the opposite divided by the hypotenuse, so the opposite divided by the hypotenuse will give you the sine of the angle. And the cos vita is equal to the adjacent divided by the hypotenuse. So if you divide the adjacent by the hypotenuse, you'll find the cos of the angle. So now that we know how to label the sides of the right angle triangle, and we know the trigonometric ratios, we're ready to find the size of missing angles using trigonometry. So let's have a look at our first example. So we've got a right angle triangle. We've got the length of this side is 40 centimeters. We've got the length of this side is 50 centimeters, and we want to find the size of this angle vita. So to find the size of this angle, we're going to be using trigonometry. Okay, so let's write down our trig ratios. Our trig ratios are the tan of vita, the tan of the angle, is equal to the opposite divided by the adjacent. The sine vita, the sine of the angle, is equal to the opposite divided by the hypotenuse. And the cos of the angle, cos vita, is equal to the adjacent divided by the hypotenuse. So whenever I'm doing a trigonometry question, I tend to just jot those down to begin with. Now we've got our right angle triangle. Let's label the sides of the right angle triangle. So the side opposite the right angle, this side here, will be the hypotenuse. So that's h for the hypotenuse. We're trying to find the size of this angle, so the side opposite that angle would be this side, so that's the opposite, the 40 centimeters is the opposite, and that means the side that we've got left, this 50 centimeters, will be the adjacent, so that's the adjacent. Now in a trigonometry question, two of the sides are going to be involved in the question. So here we can see we're going to be using the opposite and the adjacent because they've both been given to us, whereas the hypotenuse we've not been given and we're not trying to find it. So we can cross off the hypotenuse, we're not going to be using the hypotenuse. So that means in terms of our trigonometric ratios, our trig ratios, any of those trig ratios that involve the hypotenuse we can cross out. So in this question, sine has got the hypotenuse, so we can cross it off, we're not using sine, and cos has also got the hypotenuse, so we can cross that off. So we're not using sine and we're not using cos. So in this question we're going to be using tan. So let's write that down. The tan vita is equal to the opposite divided by the adjacent. So we're using that trig ratio in this question. Now let's substitute in our values. We've got the tan of vita, so the tan of vita is equal to the opposite. So in this question the opposite is 40 centimeters. So instead of writing O, we're going to write 40 divided by the adjacent, and the adjacent is 50 centimeters. So that's divided by 50. So we've got the tan of vita, the tan of this angle is equal to 40 divided by 50. So you could do 40 divided by 50 in your calculator if you want to at this stage, and you get the tan vita is equal to 0.8. So you could do that if you wanted to. And I tend to just leave it like that, as tan vita equals 40 over 50, just as a fraction. So we've got that the tan of this angle is equal to 40 fiftieths, or 0.8, or 4/5. But we want to find the size of this angle. This angle obviously isn't 0.8 degrees or 4/5 of a degree. It looks much bigger than that. So we want to find the size of that angle. So we want to find what vita is. So if we know what the tan of the angle is, and we want to find out what vita is, we need to do the inverse operation. So to get rid of the tan, we need to do the inverse operation. So that would give us that vita, the size of the angle, is equal to, and the inverse of tan is the inverse tan. So tan with a little -1, like so. That's the inverse tan, or arc tan, or on your calculator you can press shift tan. So we need to do the inverse tan of 40 fiftieths, like so. So we need to do the inverse tan of 40 fiftieths. And whenever we press shift tan on our calculator, it opens up brackets, and then we'll type in 40 over 50 as a fraction, close brackets, and press equals. And when we do that, we get the vita is equal to 38.6598 and so on degrees. So the size of this angle here is 38.6598 and so on degrees. Now let's just round that to two decimal places. So the two decimal places, this angle would be vita is equal to 38.6, and then we've got 59, so let's round up to 66 degrees, to two decimal places, and that's it. So that's it. So we've used trigonometry to find the size of this angle. Okay, let's have a look at our next question. Okay, so here we've got another right angle triangle, and we want to find the size of this angle. So again, let's write down our trigonometric ratios. So they are two old angels. Tan vita is equal to the opposite divided by the adjacent. Skipped over heaven, so sine vita is equal to the opposite divided by the hypotenuse. Carrying a harp, so that's cos vita is equal to the adjacent divided by the hypotenuse. So we've got our trig ratios, and let's label the sides of this triangle. So we've got our right angle, so the side opposite the right angle will be the hypotenuse. So our 20 centimeters is the longest side of this right angle triangle, so it's the hypotenuse. We're trying to find the size of this angle, so the side opposite it, the side will be the opposite, and the side that we've got left will be the adjacent, so the 9 centimeters is the adjacent. So in this question, we're going to be using two of our sides. We're going to be using the adjacent, the 9 centimeters. We're going to be using the hypotenuse, which is 20 centimeters. But we're not trying to find, and we've not been given the opposite, so we don't need to use the opposite in this question. So let's have a look at our trig ratios and cross off any trig ratio that involves the opposite. So we're not going to be using tan because it's got the opposite, and we're not going to be using sine because it's got the opposite. So in this question, we're going to be using cos. So let's write that down. Cos vita is equal to the adjacent divided by the hypotenuse. Now let's substitute our values. Now in this question, it's the cos of the angle. Now the angle in this question isn't labelled vita, it's labelled x. Sometimes that will happen. Instead of the angle being labelled vita, it might be labelled x or y or anything really. So instead of writing cos vita, I'm going to write cos x, just replacing the vita with the x, the angle, is equal to the adjacent. So the adjacent is 9 centimeters, so 9 divided by the hypotenuse, which is 20. So the cos of this angle is 9/20. Now if you wanted to, you could do 9 divided by 20 on your calculator and get 0.45, and you'd have the cos of x is equal to 0.45. Alternatively, you could just leave it as a fraction. That's what I tend to do. Now we want to find the size of x. This angle obviously isn't 9/20 or 0.45 degrees. It's much bigger than that. So what we want to do is we want to find the size of the angle. So we want to find out what x is. So we want to get rid of the cos. So to get rid of the cos, we need to do the inverse operation. So we need to do x equals the inverse cos, or cos minus 1, like so, and then 9/20. So we've got that the x is equal to the inverse cos of 9/20. So on our calculator, we'll press shift cos, and then our fraction button, 9 and then 20ths, close brackets, and then press equals. And we get that x is equal to 63.2563 and so on degrees. So the size of that angle, x, is equal to 63.2563 and so on degrees. And we can round that. Let's round that to 2 decimal places. So that means that x is equal to 63.2. Now we've got 5/6, so let's round up. So that'll be 0.26 degrees to 2 decimal places, to 2 decimal places. And that's it. So that's the size of that angle. Okay, let's have a look at our next example. So our next example says, calculate the size of angle DEF. So we've got this right angle triangle, DEF, and we can see it's a right angle triangle because that's labelled in the bottom right corner, like so. And we know that the length of DF is 5 centimetres, the length of DE is 13 centimetres, and we've been asked to find the size of angle DEF. So let's label angle DEF on our triangle. So DEF, so we'll start at D, we'll go to E, and then we'll go to F. So that's going to be that angle there. So that's the angle we're trying to find. And let's label it. I'm going to call it vita. So we're going to find the size of that angle, and I'm going to call it vita to begin with. So let's write down our trig ratios. They are tan vita is equal to the opposite divided by the adjacent. The sine vita is equal to the opposite divided by the hypotenuse. And that cos vita is equal to the adjacent divided by the hypotenuse. So they are trig ratios. Remember, 2 old angels skipped over heaven carrying a harp or saw ka toa. So there are trig ratios. Now let's label the sides of our right angle triangle. So here's our right angle. So the side opposite it will be the hypotenuse. So that means that this side will be, this side here will be the hypotenuse. But we're trying to find the size of this angle. So the side opposite that angle will be the opposite. So that means that the side here at the bottom will be the opposite. So that's the O, the opposite. And that means the side that we've got left, EF, will be the adjacent. Now in this question, we're going to be using two of our sides. So we're going to be using the opposite, the 5 centimetres. We're going to be using the hypotenuse, which is the 13 centimetres, but we're not going to be using, and we're not trying to find the adjacent. So we can cross that off, and any trig ratio that involves the adjacent, we're not going to be using. So we're not going to be using tan, and we're not going to be using cos. So in this question, we're going to be using sine. The sine of the angle is equal to the opposite divided by the hypotenuse. So let's write that down. The sine of vita is equal to the opposite divided by the hypotenuse. Now let's substitute our values. So the sine of vita, the sine of the angle, so the angle we've labelled it as vita, so we can just write that down. The sine of vita is equal to the opposite, so the opposite is 5 centimetres, that's 5, divided by the hypotenuse, which is 13, so 5/13. So the sine of this angle is 5/13. Now this angle obviously isn't 5/13 of a degree, it's going to be much bigger than that. So what we need to do is get rid of our sine. We just want to find out what vita is. So we need to do the inverse sine. So we're going to do sine minus 1, and then open up our brackets, and then we're going to write 5/13. Now again, we could write this as a decimal, and we could do our inverse sine of that decimal number, but I just like to do it as a fraction. So shift sine of, and then fraction button, 5/13, and then close brackets and press equals, and we get the vita is equal to 22.61986 and so on degrees. So that's great. We've found the size of angle DEF. The size of angle DEF is 22.6, and let's just round this to 62 degrees to 2 decimal places, and that's it. And that's it. So in this video, we've looked at how to use trigonometry to find the size of missing angles and right angle triangles. And I really hope you found this video useful. If you have found it useful, please like and please subscribe to the YouTube channel. Thank you. Cheers. Bye.